So, very good morning to all, and it may be good afternoon or evening from all the participants across the globe. So, on behalf of the organizing committee, I, Dr. Lohit Kumar, a coordinator of this particular event, welcome you all for this last day of this event, day 4 session. So, this event is being this event is being organized by the Department of Civil Engineering, IIT ISM Dhanbad, and jointly with the Department of Civil Materials and Environmental Engineering, University of Illinois at Chicago, and sponsored by the SPARC for Promotion of Academic and Research Collaboration, SPARC, Government of India. So I warmly welcome you all for this particular 4-day event, International Virtual Short-Term course on futuristic prospects of geoenvironmental and geotechnical issues of coal mine overburden. So coming to today's session, so we are having speakers and the topics. That is, the first lecture will be delivered by the Dr. Mayu and followed by Professor D.N. Singh, and lastly it will be Dr. Oznur Kanka, and at the end we will be having a closing session. So before proceeding with our next session, I would like to make a small announcement over here. Since most of the participants were requesting about this particular certificate, so I'd like to make clear over here that the participants attending a minimum of the 4 lectures across the globe. This is being done looking into the participants participating from across the globe, which may be feasible for them to join this particular events. So we have decided a participant attending a minimum of 4 lectures will be issued a certificate of participation. So with this, I invite Professor Sharat Kumar Das, Indian convener, to kindly welcome our first lecturer and to host this particular session. Please, sir.
Hello, everybody. So as Dr. Lohit Kumar has already said, we are working on that time with different places. So today our speaker is Dr. Mayu Tincopa. He is a general manager, Contec, Peru. So Dr. Mayu Tincopa is a civil engineer from Universidad Nacional de Ingeniería, Peru. He did his master's degree from Barcelona Tech, Spain, and PhD from Monash University, Australia, in geotechnical engineering. He has more than 7 years of experience on this geotechnical project, in which he has been involved in projects related to numerical analysis, field science investigation, and geotechnical engineering. Since last 3 days, we are talking about on different aspects of tailings and also different numerical modeling. So now we are going to listen from Dr. Mayu about the relevance of site investigation in tailing dam and mostly in situ investigations. And with the experience that he is currently the general manager at Contec, Peru, he is also having the academic experience as a lecturer on geotechnical engineering course at Universidad de Ingeniería Tecnología. So now I request Dr. Mayu, please start your presentation.
Thank you for the presentation, Dr. Das. I'm gonna try this way. Hopefully, looks nice, and it's a different way to present this lecture. So I just, before starting, I just want to thank for the invitation. Hopefully, this lecture is interesting for everyone. I will try to give a really brief overview of site investigation, a more broad idea. So my name is Mayu Tincopa. I am from Peru. I've been working on site investigation, I think, most of the time. This is the last three years, very specific in site investigation, but I've been doing work on geotechnical engineer from consulting and different type of related geotechnical aspect. So the topic for today is the relevance of size investigation on tailing dams. Let me begin with some information about context, just to give a broad idea about the brand. Well, we have 4 main cores in the company: is safety, quality, people, and equipment. We are focused on putting these 4 cores together and make sure we are delivering the best data for size investigation. So that's something to keep in mind. Contact is around the world in 20 offices throughout the Americas and Australia. Actually, they recently opened 1 year ago the office in Australia. So we are growing a lot because this, as you will see, size investigation is a key part of tailing dams, and in general in any geotechnical investigation, it's important to take it. So we have different type of rigs. One of them are the drill rigs. We have direct push rigs. I will show some photos in the presentation. We have amphibious, which is very good for tailings, which are wet, very wet. We have seabed whenever we want to put it on the sea, and barrage as well for lakes, as well for tailing dams as well. So this is a bit overview of context. So proposal size investigation. Actually, this proposal size investigation is just, as you will see, is a basic critical thinking, how we should optimize our size investigation. And I will show you 2 cases. Once I showed it, I present this proposal for size investigation. I will show you 2 cases that I've been involved, and they were very interesting because you can see that we can do better in our size investigation, and we can propose a better set of tests. I will show you later on, and at the end I will give the summary of the presentation. I would like to begin with this photo. It's one of the photos that I really like it, because as a geotechnical engineering, everyone think that the technique you use to explore the soil, the subsoil, it's the best. Geophysics, for example, in the left, or in this case, pushing SPT or CPT, whatever. And these 2 people have different view of the soil profile. But as you can see, both are right, but they are very specific view where are they doing the test. So as most of you are aware, we need to have a really good view, and I really like this about geological engineers, because they can see the soil as a big picture, instead of just have a small narrow, this is going to be my footing, so I need to focus on my footing instead of focus on the whole picture. So that's something that I would like to share, and this is a message that we should be careful what tests we use, and we should try to focus on the big picture instead of on really specific. So as you can see, the soil has a lot of uncertainties, and we need to make sure we get as better as possible information from the subsoil whenever we are doing our size investigation. This graph, I took it from the Clayton book. What I found is very interesting is that they have this correlationship, but this is they apply this for right wells, but actually I think you can apply as well for any type of size investigation. So what you can see here is like, if you imagine like in the vertical, what they say is in the vertical axis you have the total increase of construction costs of tender price. So what does that mean? If you have already a budget for your construction, and and you invest in the horizontal axis, you have the size investigation cost. A percentage of this size investigation. So if you invest 2%, 6%, you will have a different amount according to this this plot. You will have different amount of increase of the budget. So what does that mean? I can put an example here, and it will be best to illustrate what I want to show here. If you have a 5 million budget for your construction, you can talk about any type of construction, and then you invest. I like to call this investment for size investigation instead of calling spending or spending money in size investigation. So if you invest 2%, which means if you get 2% of the total budget, is around $100,000 dollars. So the increment of cost, according to this graph, you will get almost 3 millions, and this is the red one. So this means a lot. So then you will have 8 million spending on your project. This is example for sure. But if you invest 6% instead of 2%, and which means $300,000, your increment on the cost will be just 1 million. And if you do the math, you will see that just the investment of $200,000 more on your size investigation might lead you to a potential saving of about 2 millions in this example. I know this is a rough number, but they can give you a picture of what is happening if you invest a little bit more on your size investigation instead of avoiding this investment. So far, what I want to say is, getting the good information from the subsoil is important for your project, and there is a lot of tools on the market. I think the conventional one, as most of us knows from the books, very well known, are the drilling, sampling, and then getting sample from the soil with the typical thin wall, and do DMT, different type of tests, SPT, bench shear test as well. So all of them are very conventional one, and they are good. We are using, but the way we usually do are very time consuming. This is a fact. Could take a lot of time, and I will show you later on how much time could take to do this type of tests. And then the other side, which is kind of the new trend and the new way of approach the size investigation, is by using the direct push technology. What is happening in this technology is that now you can push a cone with a very big rig, heavy one, 20, 25 tons, and you can do most of the tests that you used to do with the conventional drilling procedure. So you can do bench shear tests if you push, especially in tailings. You can do piezometer. You can do some installation of piezometer. So instrumentation is as well part of the task or duties that you can do with the push technology. The CPT and all that type of seismic CPT, resistivity CPT, gamma CPT in some cases. So you have so many type of variation that is going on with time. Actually, there is now a way you can take a photos of your profile when you push the cone. Then you have as well sampling with the pushing technology. You have DMT, which is well known as well, that you can do with the pushing, just pushing the plate from the dilatometer test. You can do dilatometer tests each 1 meter, each half meter, so on. So what I want to show here is not just one is good and one is bad. I want to tell you that both are something that you need to assess, and you need to take the best decision when I should use one or when should I use the other one, because that performance, and you will see here, it's different, and you can get good approach, especially in tailings, with the push technology. My opinion is that you should think carefully and use both in the best way to get the best from your size investigation and from your budget as well. So what is the proposal size characterization investigation is based on it's a simple approach. It's just a way to think about it, how from the general and to specific. What is the general is what application do I assess? If I am talking, you will see that we are talking about tailing dams, we are talking about foundation, deep foundation, we're talking about ground improvement, so on. What is the level of risk that you are involved? This is the second part of the analysis that you should ask yourself when you are proposing your size investigation. The third part is, as you can see, is the problems. Which are the potential problems? What I mean with problems is more like a geotechnical problems. We're talking about liquefaction, we're talking about settlements, and we're talking about flow, groundwater, and so on. And the fourth level, like if you are getting narrow to this general to specific, is what key parameters are you looking for? Especially if you're talking about liquefaction, for sure, the parameter that come to your mind, and I think most of you have been listening, is the state parameter. So the state parameter is one that you should use it, and you should assess as a key component when you are doing a liquefaction analysis. What field and lab tests do I need? That's the fifth question that is important, because then, okay, now I know which one is my problem, what is the parameter that I am looking for, how big is the risk, is it low risk, we are talking about different projects, and I will go in detail of each of these points that I am showing here, but this is the framework, basically. So you go from the general to specific. This process leads you to a decision. Okay, I need, this amount of CPDs, this amount of drilling, and I need some DMT because I am focused on getting this deformation parameters, or we are looking for permeability, for example. So that's the framework that we will use over these steps. So what is the application that I assessed? Here you can see a tailing dam. Actually, this is a Peruvian in Peru. So what do you assess in this case? Are you looking for tailing dams? Are you doing a job for the foundation, as I say, ground improvement? Heap leach pad is very well known here as well as it's a mining facility. And from my experience, I would say it's very, very interesting structure that they have. They can have a lot of problems. I think minings does a good job by looking after these facilities as much as they can, because there's very complex, and the problem you can find in heap leach pad, as you can see in tailing dams, liquefaction is one of them, is important and relevant for geotechnical engineering. So once you know, okay, I have what is my application is tailing dams. What is the risk, the level of risk? I know this is a picture just to illustrate. I like it because show a 4 level of risk that you can describe yourself. One is, for example, that the typical low probability, low impact. So that's the second one. So you just basically has a pit here, and even if you can walk there, you will not have a problem, and you will not fall on this pit. The first one is high probability and low impact. So what happens if you walk around? You are for sure they will have some accident, whatever, or you just you will get in trouble, but the impact is low, so will be not really a big impact. Then we have the third one, which is low probability, high impact. So it's a narrow pit, but the high or the depth is, and then on the depth you have a lot of damage if you drop on this hole. No, and the same for the high probability and high impact. So those are the type of risk that you can you can imagine in your mind. But in geotechnical engineer, I like to use the one approach by Robertson in his book in 2014. He showed a really nice way to say, okay, if you are talking about low risk project, moderate risk project, or high risk project, then you need to be aware that you should use this type of size investigation, this type of test as well. You know, he give you a suggestion, which is nice, and then you can take it as your criteria, which one is best. But I think in tailing dams, most of the time, the risk is very high. So you should be careful and do as much ground investigation as you can do. In situ tests, you should do. This is a progressive. So the basic low risk I can show you is very simple. Getting samples, classify the soil, make sure this is a sand, a clay. You know exactly what you are dealing with, and then do some field tests, very specific in some points. And that's all. I would use some correlation from the literature. But then if you move to the second one, which is the moderate risk, then you need to do more details on your size investigation. So you use as well the ground investigation as the low risk. Plus you need to add some, okay, now we need to be more specific with the size investigation. Maybe we need to do pressurometer, more tests, to more sophisticated tests. We need to do some size specific correlation, just to use lab tests and try to make a correlation what you have on the field on the lab. So very basic. But then if you move again to the next level, which is more, you know, critical one, and you need to try to get the best information from the site, then you will see that you will need really high quality test, sampling, very high quality lab tests, do some specific cycling tests. For example, if you're talking about earthquake areas, and so on. You know, you need to make sure you have your correlation for that size. You know, in this case, I think very specific for tailings, because this type of structure, as you can see, they are a structure that they will grow over time, and they can have initial state from 2 years ago, 3 years ago, and then do it to different criteria operation on the tailings. This will change the parameters, or will change the properties of the soil. Anyway, so the third one, once the first one was to just, you're talking about tailings. The second one, we classify, and we know the tailings are very important. We need to put in the high risk, and we need to make our own correlation, make sure we have enough data, and getting the best tests that we can to make sure we understand that the tailings. As you know, most of you already knows, tailing dams are very specific material that actually can change from one mine to another one. For sure, change because of the crushed rock you are having this type of tailings, and so on, all the chemical involved as well. So anyway, the third level is which are the potential problems. So which are the potential problems? As you can see here, this is a photo of Brumadinho. The potential problem here was liquefaction, and then you have a flow going through the slope, destroying or damage everything around that area. So that's a big problem for sure, economical problem, and as well social impact on the community. So this type of third level is pretty much, you need to say, okay, well, the liquefaction is the problem. I think this is the key one that we need to tackle, and we are sure this is a typical problem on this type of structure. The consolidation could be, I mean, it's not in tailings, but could be in different cases depending on what you are assessing. Slope stability, for sure. If you are talking about slope stability from the dike or from the dam, then you can have another bearing capacity if you are talking about shallow foundation, or we are talking about retaining walls for other type of projects. So you need to classify and make sure, okay, we are talking about this problem, and we know this problem is going to be the key for this type of application, and so on. So here is the fourth level. In the fourth level, as you can see, we are getting narrow. We are getting narrow. We are trying to make sure we understand more in detail. It's a way of, it's a critical thinking. It's just, okay, it's very basic, looks very basic, but trust me, I saw a lot of people that they just, go for drilling and without thinking, okay, what type of drilling and what type of sampling quality do you want? And so this type of question that I am showing here is good to start with what you want for your project. So which are the key parameters? In this picture, I try to show just, for example, if you're talking gravity, you maybe in this case, the friction angle is important. If you're talking about sand, maybe the junk model is important. So you need to understand which of these geotechnical parameters we are talking about, and it's going to be a key. For example, I think we are talking about tailings all over these 3 days, and we know that the state parameter is going to be the key parameter for liquefaction. So we know that for sure. So now we recognize that liquefaction is a problem. So the key parameter that we need to get, not just with the CPT, we need to get this state parameter with different type of tests, or we need to make sure we can get, for example, the other parameter which is important is the hydraulic conductivity. Hydraulic conductivity you can get from the CPT doing the dissipation test. For example, you can do a lab test and get the hydraulic conductivity. You can go and do some Lefran or Lujon tests, which is like just on the drilling, on the borehole, do a test in situ. So this type of way, you need, okay, if this is going to be my key parameter, I need to make sure we are getting 2-3 times measurement of this parameter to assess, okay, this is going to make sense. In this case, we do a really good test. In this case, we are covering all the area. In this case, we're just specific for a sampling at 30 meters and so on. So that state, or that four part of the question is just to make sure you already know which parameter is involved. And then I think most of us know, if you are talking about junk models, we know that we should do pressurimeter, we should do DMT, we should go for some tests, triaxial tests to get the junk model, or odometer to as well get the constraint model. So we know already, if you're talking about one parameter, which type of tests are related to this parameter to some extent. So finally, once you already do this critical thinking and just make sure your project is fit to each of these state, then the last part is to, okay, then let's give them the lab and the field test that I need. Which one are there? You have a wide range of tests that you can do on the field, or you can do on the lab. I like to classify these in 3 ones. You can do drilling, you can do direct push technology, at least this is for field tests, and you can do geophysics. I think these 3 ones, at least it's very well known. And inside of each one, you have tests like SPT, you have vein tests, you have piezometers, you can do piezometer installation of piezometers. Pumping tests, if you're really focused on permeability, you should go for pumping, which is really good type of tests. Expensive for sure, time consuming as well, but it's a test that you will rely more whenever you are focused on hydraulic conductivity, for example. Direct push technology as well, you have more tests as I show you. CPT, very well known, bencher test, flat odometer sampling, you can do some sampling as well. Very small sampling with the push technology, especially in tailings. This is very, I think push technology has grown a lot from tailings dam. They had this type of a structure has the opportunity to, because it's very soft. You can do with the push technology a lot of different type of tests or different type of instrumentation, for example. My opinion right now is in the future we will keep going as we are improving drilling. For example, PMT is a type of test that is improving over time. Now you can do the PMT just doing your self-boring PMT, but the same way direct push technology is growing a lot. And I will say the same for geophysics. Now we have more type of geophysics tests for geotechnical aspects. So this is good. This is good. I think that the trend is that things are moving forward. We're getting more type of information, different qualities, different Even I didn't mention here, and I think it's the technology that is moving, is the drones and all this all information from the satellite that you can get from the soils. And this is as well important because all of these tests you should use wise, and you should make sure you are taking these tests because you're looking for this information, and that's what is before this lecture is about. You need to do this critical thinking whenever you're doing a project for size investigation. So this is the 3 ways that I classify the field test, and the other one is the which lab test do I need. In this case, I classify according to the parameter you can get, like the main one. I think the basic one is soil structure. You understand the soil structure when you do this size grain, unit weight, the water content, all the limit liquid, all these tests give you a really good idea of the soil you are working on. And then the other one are related to strain, triaxial, very sophisticated one, share box, odometers. They are all related to the formation of the soil. And then you have flow as well for flow. So we were talking about permeability, we're talking about consolidation as well. We are talking about water retention curve, which is important when you are analyzing seed page, or you need to understand how the water moves through the groundwater. So that's a parameter you need to get to do this in the best way. And dynamic as well. If you are in an earthquake country like Peru, for example, you need to do some tests as well if really your focus is to understand what could happen if there is an earthquake in your dam, for example. So that's the way. Once you classify these, then you can really understand. Again, if your problem is flow, you know that you should do at least one of these tests, depending of the risk level that you classify your project. We are talking about high risk, so we should go for it for the most of the tests that you have there. So the message that I want you should take it to home today is you need to optimize the tests, and this is something that is not about using more drilling and you will get better size investigation. You will do much push technology and you will get better size investigation. That's not. Or you will do more geophysics and then you will get the best size investigation. I think that's not the way. You need to do this critical thinking that I showed today. And try to focus on the key parameters. Try to focus on the key problems that you are dealing with. And the way I just mentioned here in the like example is identify the problem. The higher the risk, the higher the number of tests that you need to convey. Choose the key parameters, which is the key parameter. Allocate the field tests, allocate the lab tests according to your type of. If it's a tailings, for sure you are interested in the dam. You're interested in the different part of the dam. So that's the message for this part of the lecture. So pretty much what I try to say: be aware that you need to take the test that really need you for your size investigation and for your project. So now I want to show you in this part, and it's going to be short, but it's going to use what we did in the previous slides. It's application case. There are 2 projects that I've been involved, and most of them both are in tailing dams. Before that, I would like to show you some equipment we have as well in Peru. They are very related to mining and to any infrastructure facility. We have this type of CPT rigs. We have some sonic rig, which is as well, again, this sonic rig will be good. And actually this sonic rig you can combine with CPT as well. So they have a lot of advantage. Each rig has a different advantage. And the one we have here is the rotary rig, a typical rotary rig. But you have, in this case, SPT, CPT, and all these tests, you can do it on this rig as well. All of these tests, you can do CPT, which is our main test that we are doing in our job. So I like to, before I show you these examples or these cases studies, I like to always talk about these two figures. And in the left side is your body, and I like to get this analogy because your body, you know, you can do blood sampling, you can do blood pressure, body mass index, and temperature. You can measure all of them, and you can get a good idea of what is your problem. You know, for example, if you are with you know, you have a virus, or you have you know, now with the COVID, you need to take on all these tests and make sure, okay, now it makes sense, you have this type of problem, you know, and for this problem you need this type of solution. So in the same way, I think we should treat our tailings and or any structure facility in general. So you need to do some samplings, some soil samplings, and recognize the soil. You need to do some, in this case, I put it as a CPT, for example, the tip resistance. You need to get the tip resistance along the profile. You need to get the slip resistance, and you need to get the pull pressure of your structure. So if you get this information, and this is just example, but you can get more information from the tailings, you share wave velocity, for example. So if you get this information, then you will really understand, and you can get a good, you can get a clue what actually is happening on you as your body. You can get a good clue what is happening on the tailing dam. So that's what I want to show here is you should treat your structure as is could be your body. And here I just illustrate what I mean with the previous slide. What would you like to get for your a good medical assessment? What would you like to get a good medical assessment? So yeah, if you go to the left, I be a bit sarcastic here. Yeah, you have a way to measure if you have a fever, for example, and you need to measure how many pulse you have each in 1 minute, right? 1 minute, on 60 seconds. And then if you know it's going to be more than 80, more than 90, you know, you have some really high temperature, and the doctor say, okay, you are sick. But he's not so sure what is happening. So he knows that there is something wrong, and he's measuring one thing from your body, and that's all. And I like to relate that to SPT in a sarcastic way, because you get a number of blood counts, and that's the way you do that. You get a sample, that's true, but and that's advantage that the SPT has. But now you can get a sample as well from the push technology, which is another advantage you can do as well. Anyway, so then you have in the right side other way to measure or to assess your medical assessment. You know, measure your temperature with a sophisticated instrument, and recognize, okay, you actually in your head is really hot, and in your neck is not so hot, so maybe it's related to you have a headache, or you have a, you know, something related to a specific thing. Then you can measure with another instrument, very sophisticated instrument. You can measure your blood pressure. You can get some, as you can see here, blood tests, and see if you have high sugar or high amount of a specific type of measurement of your body, and then pressure as well. So the way you are measuring different type of part of your body, and getting an output. The output is, yeah, this is the reason, makes sense. You validate that actually, yeah, makes sense. The temperature is very, very high because you have really high pressure, and the high pressure is really bad because as well your amount of oxygen, for example, is low, whatever. So the idea is that you see here that you have more tools to take a assessment from just one tool that doesn't give you too much information. At the end of the day, you want to have much information as possible. That's as a geotechnical engineer is our goal. And based on this amount of quality information, not just a lot of information, it's just a quality information, then you can take a decision of your design parameters, of what solution is the best, and so on. So in this project, just go on to the application case. This is a closure of a tailing dams in the center of Peru. we use this type of rigs in this project. The picture is not right at the project, but yeah, it's quite similar, just to make sure this is not really specific to the mining. We are not talking about the mining. So in this project was a closure tailing dam. They already, it's all tailings, and they did this. They construct these tailings upstream construction, which means you have a start dam and then the dams going up to the tailings. So what we did here is 12 CPTs, or seismic CPTs. We did 48 vein tests. We did some as well, some piezometer installation, a lot as well. I think 2 piezometer installation from each point. We did like a 3 or 4 bencher tests in each point as well. As well, what we did here, apart from the instrumentation, bencher test, that's as well in that list. So what was the goal here is to make sure, okay, we need to design what is going to be the slope for this closure, and they were designing the slope and make sure the stability in the long term is going to be right. And then if they don't have any potential of liquefaction as well, that was another key component of this study. Here, I'm going to show you a CPT data. So I think this project was really nice because we optimized time, we optimized the data, the amount of information and the quality information we get was really nice. For example, here you can see this type of small, narrow, weak soil. It's really difficult to get it from drilling. That's one thing, for example. And then you can clearly see as well, you can get the BS, the BP, the bencher test, but the shear wave velocity, the P velocity, and based on these two, you can get the quotient ratio as well from a correlation sheet. You can do some dissipation tests as well and get some information about the permeability and so on. So what I want to show here is that the quality of data is really good for tailings. It's very, very nice. I actually didn't show you here the bencher test, but there's some bencher tests and you can, do a cross check with your CPT or even calibrate your CPT with this bencher test. This is the one that I want to show you. What is happening here, we did this project based on, we did some sampling as well in this project. I forgot to mention. We did a lot of sampling, just in the specific, what was the sampling? The sampling were very specific, one here, and one in this one. So once you have the CPT, what we usually do in this type of project, then you can do all with push technology, is do a CPT. From the CPT, you can get this information on the day, or the next day you already have the data and you can, okay, now the next day we know that we have this type of really weak soil, we have another type of soil here that we need to identify what type really soil is based on lab tests. So you can go get a sample here, do a bencher test here, do the sample, get a sample here, do a bencher test here as well. So that's the way we usually approach a project when we are doing all these type of tests now. And the good thing about push technology is that the performance and the ratio of information you can get here, it's good. For example, 12 soundings, almost 500 meters. We did it actually in 8 days. So that's pretty amazing and pretty good for you as a geotechnical engineer, because you are getting all this information. I think if you multiply for every 2.5 centimeters, you will see the amount of data you have. And not only that, you can do all this correlation as well that will help you to understand more the soil. Then you have bencher tests as well. We did this amount, 48 bencher tests. We did 44 sampling with this type of size. This sampling is basically for getting the moisture content and getting the soil classification of this soil. Piezometer, we did some piezometer installation as well. All this work was 39 days. This is the meter of total meter we did in this project. and then the amount of sanding as well. So what this is actually what is happening. But in the bottom, what I did is just, in this case, we assume what is happening if we do this job with the rotary drilling, with the typical conventional drilling. So what will you do is if you don't have push technology? You will go for drilling, and then from drilling you will do some SPT and sampling as well. You do some BST and piezometer. This is the same way, you know. You need to do a piezometer as well, the Casagrande piezometer, typical one. So what is happening here? If you see the numbers, you will get 880 days, and this is a really best scenario for this type, the same scope. You will do it almost two times or more than 2 times the time that will take to do it with the push technology. That's important, and that's something that you need to assess. Now, I don't want to say go for push technology and forget about drilling. I think that's not the answer. The answer is go in the middle, go and find the balance between getting push technology and getting some rotary drilling or sonic drilling as well, if the project deserves it, or the project is required to do that as well. So then I show in the last part proposal size investigation, which I do a combination of both. Try to get some drilling because it will be good to have a profile, a career profile on where is the rock, and then get as well some push technology and do some CPTs, bench tests, and piezometer installation and so on. So at the end of the day, I like to see this type in the figure, which is like this, and you will see that you will get more meter of investigation, and you will get in more sounding as well, more boreholes, and more piece of information around your area, and in a less day, not as short as you can get with the push technology, but you will find a middle point between the rotary and the push technology, which is still okay. You know that the time is money as well in this case, as well. If you have this information as soon as possible, all this project could move forward and go do a save some money as well. Again, this is kind of investment. Sorry, I just put this chat that I should remove. Okay, so here again is the same way. I just forgot to translate perforación, which is drilling, but in the graphical way, you can see that you have less amount of drilling in one side and more drilling here, and you can cover more area with the combination of both type of technique. So the last case that I want to show you, I was working actually in this project. I was there with, I don't have a photo there. I have a photo, but I didn't put it there. I was doing the CPT, and it was really nice because you actually can, I really like to be in the field. You can feel what is happening. You can see what is doing right. What is the water level? What are they doing that? Why is this, the mountain around? I think it's really nice. I think as a geotechnical engineer, you need to go to the field and enjoy get dirty with the tailings in this case, or with the soil. So this is in the south of Peru. Again, in this is it's an old tailing. What happened here? They want to reuse the tailing dam because this was an old tailing dam again, and there was some really good. They found the opportunity with the new technology, to recover more mineral from this old tailing, because I think in the past the technology was not good enough to recover as much as possible of the ore material. But anyway, here that was the goal, but they were gonna do like an open pit here and start removing all these tailings and moving to the plant. So if you're gonna do that, you are doing actually excavation, and you will you might have a problem with your stability in the different levels that you will have here, or you will have a problem of consolidation, or you will have problem of your groundwater here. So there was very complex project, and I was happy to be involved on this. This is a profile of this site. Again, you can see these really interesting weak layers, which are located in a different depths, and they are the ones that could give you a nightmare or could give you a headache if you don't look after or get good information of the andronate share strength, or if you don't get a really good understanding how strong or how weak are these SPARC. No? So that's something that conventional drilling cannot do. Then again, I did the same procedure. What I want to show you here is the best choice for, as a geotechnical engineer to convey a size investigation, or to convey a size proposal size investigation. So here is the push technology. This is a real data, like this is a real performance, this is a real sounding that they did for this project. And in the previous one, the rotary drilling was like a suggestion if we do it the same as the push technology. But here they do push technology, which means CPTs and sampling. And they did as well rotary drilling. And these are the times that took to do this job. All these tests were conducted. And then this is the proposal size. This is just, again, this is my suggestion as using the critical thinking that I show you today. So look at it here. You have already 10 days of work. We did this in 10 days, which is almost 700 meters of total of soil information. And then with sampling and with the this is resistivity seismic PSO. So that's what does that mean is whenever you use a new ladder, actually is the first one, I think at the beginning was a CPT, and you did measure the pore pressure, and now you add the U, means you measure the pore pressure. You are the S, you measure the seismic measurement, like BP and BS. And if you add the R, you are measuring the resistivity module, the resistivity, electrical resistivity of the soil, and that could be really good. I think I'm going to show you our data for resistivity as well. So rotary drilling as well, they do drillings, SPT, BST, which is bench test, Shelby's. They did some Lefranc and Luyon tests to measure the permeability of the soil in situ. They did some piezometer Casagrande piezometer installation. So here, I think you can see the days. I will show you now how much days were in total. And then the proposal size, I think, again, is a mixture. I think, especially in tailings, the drilling is important, but I think you can reduce this number and try to find the best, try to take more information from the push technology. There might be a case in other type of application that actually push technology is not suitable, and you will go for drilling because, for example, if you have the rock on the surface for sure, and you want to do some foundation, and this rock is weak, so you will go for a drilling in this case, because you know that the conventional drilling get good. You can classify the rock, you can get the RMR, and you can do more. You can get more information from drilling. So yeah, that's for sure. But I think in tailings, unfortunately, that the drilling is not so. The conventional drilling is not so suitable. So I think I am on time as well. Just to show you here the numbers. You do 10 days, 16 boreholes or soundings, and then 740 with the push technology. This is a lot actually. And then with the rotary, you do a lot of meters of investigation. Just 10 soundings, but almost 3 months 3 months working on sites, which means a lot of money actually. And the proposal size is as you can see here, a little bit more sounding, which is good. More time, but no as much as just doing drilling. And then you have more meters of data in your size. investigation in this case. So that's very nice. I show you here actually what is happening is I show you this is just with the same price. You can use the same price and you can get this amount of information. That's another important thing that I think I want to highlight. So to finalize the presentation, the talk is just this site characterization should be conducted in a way to reduce uncertainties on the soils. That's our goal. We need to get the less uncertainties from the soil. A proposed size investigation is suggested based on critical thinking, pretty much. Really sounds like a basic one, but trust me, I saw many size investigations that they don't do this critical thinking. They don't put so much attention that when you need to optimize, when you need to do this type of better use of your resource or your investment, in this case for size investigation. And a balance between budget and gathering information should be achieved. This is important. You need good quality data, and your budget should be related. Push technology and conventional drilling should be evaluated. Push technology recovery significant and high quality data rather than conventional drilling. That's something that you should keep in mind as well. Again, I think it's a balance. It's you need to go for the one which gives you the best. Both are good in different cases. Unfortunately, in tailings, I will say it's not the best choice as getting good data from the tailing dam. So that's all. Thank you very much for your attention. Hopefully, this was something interesting for you.
Yes, thank you, Dr. Mayu. So it was in fact a nice presentation, particularly on in situ testing. So this aspect actually you covered very well in our webinar. So now there are some queries. Will you take the questions now?
Sure.
Okay.
Sure.
So the first question is from Partha. So he has asked, what's your view on the role of aerial survey by drone or helicopter and use of artificial intelligence in optimizing the number of test pits, drillings required for a particular project, essentially in tailings sectors?
Yeah, I mentioned, thank you, pardon for that question. Yeah, I mentioned that, I didn't put here the drones and the survey, area of survey that is going on right now in many projects in tailings, at least. I think they are very valuable. There is one, actually, I was really interested in getting moisture from this survey. I know that they are doing that but not for geotechnical application. But I think they should be for sure the future. We should do it more often, and the technology will get better on that. Contec is not right now doing that as much as should be, but I think that this is a good opportunity for any company that are interested in this type of technology. And then artificial intelligence, we are doing artificial intelligence in Contec, and we are getting the best as from the data we collect. What we did with artificial intelligence is just, for example, we have sampling, we have already a calibrated model and from one site. And once we do another test, we already can extrapolate from this database and using the artificial intelligence, we can extrapolate moisture content of the soil. We can extrapolate another parameters that already calibrated from previously. So that's advantage. We are using that in Canada at least, but in tailings I haven't seen that type of sophistication. But we should move forward to in this type of using the artificial intelligence. And then optimization of number of test pit drilling. Yeah, I haven't seen. I know that there is some professor working or like encouraging students or academics to get involved on this type of using artificial intelligence to do. I'm not so aware of that. I not have so much experience. But the one that I showed today is actually the basic that you should have, and then move forward to the more sophisticated approach, which could be the one you mentioned. And yeah, that's I think most of the that's most of your.
Okay.
Hopefully.
Thank you. Yeah, it's okay. Next is from Kamran. So he's asking, which investigation is preferred, rotary or drilling investigation?
When I mention rotary and drilling.
Rotary or drilling investigation.
Okay.
Which investigation is preferred?
Okay, you are talking about when you.
Did I say Kamran? 1028. Yeah.
You're talking about between drilling with conventional rotary drilling and push technology, or
Yes, I think he means that push technology and drilling, because rotary drilling and this. Okay.
Yeah, the talk was actually try to show that entailing that list, my opinion is that the push technology give you, from the experience that I've been seeing, give you a really good insight and more information to assess the tailing as better as possible. Comparing with the drilling, the conventional drilling we use for our foundation or for our soil rock size investigation, it's not so good. I think we need it because we need to see what is the profile of the soil, but not as much as we should do it. I think that the numbers are overrated in my opinion sometimes. But anyway, that's my appreciation. Hopefully that answered your question.
Yeah. So last question we'll take, because we are going time. So what your view about the level of risk and economic associated with the stages of investigation and phases of the project?
Yeah, I mean the risk, it's something that you should. The good example is Brumadinho. I read the report, and Brumadinho is I don't know how. I know they were doing a lot of work, but the risk was there. When you see the report, you can see that actually, wow, there was a really potential liquefaction. The risk is really high. You have this structure, but it was too late, I guess. No, so you need to. You don't need to wait until it's too late, because that was in my opinion, there was a clear idea that there is a problem in this dam, and you are getting bigger and bigger, and you don't do anything. So that's something that you need to always assess the risk on your technical project.
Okay, sorry, there is one question I thought I'll send, but Dimitri has again he has asked a question repeated. So what you want? He has asked, from your experience, which are the crucial parameters to determine for a site remediation project? Crucial site remediation.
Yeah. In that case, for sure, the hydraulic conductivity and the water retention curve are important, because you are dealing with a flow, and in remediation you are trying to understand how the flow is going to be affected your project. But yeah, I should be more specific. I think the flow is the key, and then the strength is not going to be so important. I will say that then you have some lab tests as well that you should do it. But at least in a general way, flow is going to be the main one.
Okay. Thank you, Dr. Mayu. So thank you for the presentation and answering most of the queries. Thank you very much.
No, thank you. You.